In this video, I'm going to compute the mean and variance of a random variable, x, whose density is cosine of x between 0 and pi over 2. So the figure looks like this. This is x. This is fx of x. This is 1, 0, pi over 2. So cosine x looks like this. And for reference, I will also draw sine of x, which looks something like this. All right, so for the first part, the mean of x is the expected value of x, which is by definition the integral from minus infinity to infinity, x times fx of x dx, which evaluates to 0 to pi over 2, x times cosine x dx. Now this expression here requires integration by parts, and there are many ways you can do this, but in this video I'll be showing you a tabular method to do this, which makes it a little bit convenient. So we have to pick a first function and a second function, and the first function we have to keep integrating, and the second we keep differentiating. So let's construct a table where you integrate some functions and take derivatives of the others. So select the cosine x as the integrating function and x as the differentiating function, because we know the derivatives of x are simple. So the derivative of x is 1, the derivative of 1 is 0, the integral of cosine is sine, the integral of sine is minus cosine x, right? And you can keep doing this, but you have to stop where you get the derivative to be 0. And after that, you put like plus, minus, and then plus, and keep going on. And then if you just cross multiply these terms, you will get the solution to the integration by parts. So in this case, this just turns out to be x sine x plus cosine x. Notice there's a minus here and a minus here, which makes it plus. And then we just put the limits. So for the upper limit, we put pi over 2 times sine of pi over 2 is 1, plus cosine of pi over 2 is 0, minus 0 plus cosine of 0 is 1. So we get the mean to be pi over 2 minus 1. Okay, so the next part is the variance of x, which by definition is expected value of x squared minus expected value of x whole squared. And this we have already computed in the first part. So this evaluates to, again, 0 to pi over 2 x squared fx of x dx, minus, this is coming from the first part, which is pi over 2 minus 1 whole squared. Now again, this expression requires integration by parts, and as we did before, I will again follow the tabular method. Integrals on the top, derivatives on the bottom. Again, cosine x is a function that we will integrate, x squared is a function that will differentiate. So derivatives of x squared are 2x, derivative of 2 is 2, derivative of 2 is 0, and that's it. So the integrals are sine x, then integral of sine x is minus cosine x, and then minus sine x. Again, we will put this plus, minus, plus here, and then multiply sideways. So the expression turns out to be x squared sine x plus 2x cosine x minus 2 sine x, 0 to pi over 2. And remember, minus pi over 2 minus 1 whole squared. So let's put the upper limit. This will be pi over 2 whole squared. Sine pi over 2 is 1 plus 2 times pi over 2 is pi. Cosine pi over 2 is 0 minus 2. Sine pi over 2 is 1. So minus, now put 0. It will give you a 0 plus 0 minus 2 sine of 0 is again 0. And the remaining pi over 2 minus 1 whole squared. So this turns out to be pi squared over 4 minus 2 minus pi over 2 minus 1 whole squared, which is pi squared over 4 minus 2 minus pi squared over 4 minus pi plus 1, which will be pi squared over 4 minus 2 minus pi squared over 4 plus pi minus 1. So these two terms cancel out, and what you're left is pi minus 3. So that's the answer.